We're going to look at one more indefinite integral that requires integration by parts before we move on to definite integrals. This one looks pretty similar to the last example that we looked at. We've got the indefinite integral of x squared times e to the x power dx. So once again, I can tell that this is going to be an integration by parts problem because I have one type of function, in this case a polynomial, times another type of function, in this case an exponential. So I would consult my best choices for u. Normally I would choose a logarithm first, but in this case I don't have one. So in this case I'm going to choose u to be the next best choice, would be a polynomial or a power function, in this case just x squared. That means that dv is going to be everything that I have left over, which is underlined here in red. dv is going to be e to the x power dx. So I've selected my u and my dv, which means my next step, let's go ahead and find du. du, derivative of x squared, would be 2x times dx. And then to get, remember, to get v, I'm going to integrate both sides of this. Integrating dv, or if you want to think about it as 1 times dv, I end up with v. And then integrating the right-hand side, well, that's a nice, simple, indefinite integral. The antiderivative of e to the x power is just e to the x power. So we've got everything that we need to use integration by parts. Let's write out the formula here. It says u times v minus the integral v times du. So u, we're going to start off with x squared, times v, we said v was right here, is just e to the x power, minus the definite integral of v, once again I have e to the x power, times du, du being 2x dx. So here's what I've got. I'm going to rearrange a few terms just purely for my own personal preference. First term is fine, x squared e to the x power minus indefinite integral. I'm going to move the polynomial part, 2x, up front. 2x e to the x power dx. If you'd like to factor out this too, you certainly could. That's a constant multiple. We're allowed to do that, but I'm just going to leave it there for now. And normally my next step would be, okay, well, we need to go ahead and evaluate this indefinite integral, and once we do that, we have our solution. The slight snag that we're going to run into, though, is that this indefinite integral that I'm left with right here is actually another integration by parts problem, because I have one type of function, a polynomial of 2x, being multiplied by another type of function here, an exponential e to the x power. So you may see this pop up from time to time. There's some particularly stubborn problems that might actually require you to use integration by parts more than one time. Usually it's only two. But in this case, we're going to use it twice. The one thing I'm going to be extra super careful about is this minus sign. It's really easy to make a mistake with that minus sign, and I'll talk about why in a second. But I'm going to start this basically the same way. I'm going to pick out my u. Once again, I don't have a logarithm, so my next best choice would be this polynomial power function right here, 2x. So I'm going to take u to be 2x, which means that dv is going to be everything that's left over, e to the x power dx. So dv is e to the x power dx. So we've got our u and our dv once again, so that means that du, derivative of 2x, would be 2 times dx, and then dv over there, integrating both sides, integrating this left-hand side gives us v, and integrating the right-hand side, e to the x power, is of course e to the x power. So I've got my integration by parts formula one more time. So again, this part, I should point out, this first term, this x squared e to the x, we've already integrated. There's nothing more I really need to do, which means that's just going to come down for our next step. So we've got x squared e to the x power minus, let's see, I'm going to write out the integration by parts formula first, and here's where we need to be careful with this minus sign, because I'm actually subtracting the whole integration by parts formula, which means I need to use parentheses. I want u times v minus the integral v times du. And the reason this is important is because I'm going to have to take this minus sign and just distribute that to both terms right here. I want to subtract both terms, not just that first term. I'm going to deal with those parentheses and that minus sign towards the end of our problem, though. So x squared e to the x power, that's going to stay as it is, minus, let's see, u we said was 2x times v over here, once again, e to the x power, minus the antiderivative of v, once again, e to the x power, times du. Du in this case is just simply 2dx. And at this point, we should have something that we can integrate now. If you want to rewrite this integral so that it's a little bit easier to manage, maybe you factor out the 2 and say minus 2 times the indefinite integral of e to the x power dx, just to make it a little bit nicer. Let's carry the rest of our problem down here. We've got x squared e to the x minus, keep our parentheses just so that we don't forget, 2x e to the x power. So I'm going to go ahead, I'm going to do two more things here. First thing, this might not look like I'm doing anything, but I still have this indefinite integral that I need to evaluate. So let's go ahead and do that. I've got x squared e to the x power minus, parentheses, 2x e to the x power minus here 2 times the antiderivative of e to the x power is, of course, e to the x power, and of course, plus c. So here's what we've got. Last thing that I'm going to do is I'm going to take this minus sign and I'm going to distribute that to these two terms. I suppose if you really wanted to, you could distribute that to the plus c over there, but since c is just an arbitrary constant, it doesn't really matter whether it's positive or negative. It'll sort itself out at the end if we wanted to find a particular antiderivative. So distributing that negative sign gives us x squared e to the x power minus 2x e to the x power plus 2e to the x power, and then, of course, plus c right there. So there is our antiderivative. I don't think there's any particular trick other than obviously seeing the integration by parts formula twice and then remembering to handle this negative sign. Just be careful with that. So just be on the lookout for these problems that require integration by parts twice. If you keep at it, you will end up with the solution.